going to start lesson 3.3, which is on physical modeling. All right, here's an example of a scale model. Scale models could be smaller or larger, physical copy of an object. It's a visualization of information. It's used a lot in architecture. A full-size building is modeled at a greatly reduced scale. Shows the structure of the building, shows the exterior and sometimes the interior aesthetics and lines. For example, the picture we have up here. Large scale models may be used to see structures that are normally too small to be seen properly or seen at all. For example, a model of an insect or a molecule, or in this case, I put different types of sugars, glucose, fructose, and sucrose, to see what those look like, because clearly you can't see atoms of oxygen, hydrogen, and carbon bonded together. An aesthetic model. These are developed to look and feel like the real final product. Ergonomic testing can be done. You can evaluate it for visual appeal. It will look like, but not necessarily work like, the finished product. It can be relatively simple, consisting of solid chunks of foam, finished and painted to look like the real thing, or it can be more sophisticated, simulating the weight, the balance, the material properties. Aesthetic models are for show and not designed to be handled excessively. Remember, they're probably not fully functional. They're mainly to look at. They give non-designers a good representation of the feel and the look of the object. They can be expensive to produce. They need to have a good surface finish, and usually they be life-size. Mock-ups. Used to test ideas. They can be scale or full-size. Used to gain feedback from the users. Can be considered a prototype if it's at least somewhat functional. Now, the picture on the bottom right shows a car that was carved out of clay. This is something that automotive companies have traditionally done, and it's still used. So oftentimes when you hear mock-up, you'll see clay mock-ups. Prototype. A sample or model built to test and validate the concept of process. Provides specifications for a real working product rather than just a theoretical one. Can be developed at a wide range of fidelities and for different contexts. Developed to work from two perspectives: the point of view of the development team, who can learn by creating the product, and the point of the view of the user. The development team can learn through the user interaction and feedback. Fidelity. It's the degree to which the prototype is exactly like the finished product. The range of fidelity. You can have low fidelity, where the conceptual representation is analogous to the idea. Middle fidelity, where the representation of aspects are also included from the idea. And high fidelity, where you have a mock-up of the idea as close to possible as what the finished product will be. You can also have contexts in which you're testing your ideas. The combination of fidelity and context provide validation of an idea and or further insight for development. So if it's restricted context, it's in a very controlled environment. If it's in a general context, then it can be any user in any environment. If it's partially controlled, it's going to be the final user or the final environment where it's going to be used. And if it's totally, it has total control, total fidelity and context of the actual user, it will be used by the final user in the environment it was intended for. Instrumented physical models. They can take measurements to provide accurate quantitative feedback for analysis. Examples might be fluid flows of a hydraulic system, wind tunnels, and stress within structures. You guys have done some of this in the tower project and also potentially in aerospace.